Hello, my name is Patrick, and welcome to Speech versus Auditory Comprehension, a Science Minute. If you are a hearing speaker of English, you should have easily been able to pick out and understand my speech sounds from other noise in this video or in the background of wherever you may be watching. But how are humans able to differentiate these speech sounds from non-speech auditory stimuli? If we look to the much more thoroughly studied visual processing system as an analog, we can propose two possible models for processing auditory sensory information. In the first proposed model, in the same way that we build up a visual image based on the recognition of smaller parts, progressing from points to lines to shapes to complex figures, auditory stimulus is analyzed for more and more complex patterns. We call this a general or single stream model, since the same general pattern recognition architecture that recognizes single tones at the base level can build up to a car horn or to bells ringing all the way up to speech recognition at the highest level as the auditory information is passed up the stream. In the second proposed model, the auditory sensory input is processed and analyzed in parallel by distinct systems for speech or non-speech sounds, as well as other possible streams. There is precedence for this kind of modular and specialized processing in vision as well, with the different what and where pathways, as well as a module specializing in recognizing human facial features. This has been aptly dubbed a modular or specialized model. Since we cannot simply look inside a normal brain and watch it process sounds to get a definitive answer, our most useful evidence comes from case studies of patients with abnormal auditory processing. The most provocative cases involve two types of cortical auditory deficits: auditory agnosia and pure word deafness. Importantly, these deficits stem from damage to the brain and not to the hearing machinery itself, so patients are receiving auditory input normally. In addition to having normal hearing, sufferers of these two deficits are also able to produce speech and read and write normally. Patients with pure word deafness have great difficulty in recognizing or understanding speech sounds. They may be able to identify a speaker's gender or emotion, but they will not be able to understand the actual words they are hearing. In cases of auditory agnosia, patients can correctly identify words, but they are unable to recognize non-linguistic sounds, like a telephone ringing or a car starting. This type of split between performance is called a double dissociation and strongly indicates the existence of separate systems. This implicates distinct systems for processing speech sounds and non-speech sounds that can be affected independently of one another. Furthermore, in a single stream model, brain damage that leads to auditory agnosia should also create a dam that prevents the higher level processing by the same system to identify language patterns, which is not the case. These and other data lead us to believe that you have a specialized speech